Alright, today we're going to be talking about parallel lines and transversals, as well as proving lines are parallel. Our objective for today, we will be able to identify angle-pair relationships and use them to solve problems involving parallel lines cut by a transversal. So, our first postulate. If two parallel lines are cut by a transversal, then the pair of corresponding angles are congruent. And remember, corresponding, which we talked about last class, means in the same place. So, given that J is parallel to M, so J and M, and the way we can mark that they're parallel is by drawing arrows in the middle of the lines or on the lines, not at the ends. The ends tell us that they go on forever. Arrows on the lines mean that they are parallel. If the measure of angle 3 is 140 degrees, so angle 3, then the measure of angle 7, since angle 3 and angle 7 are corresponding angles, we know the measures are congruent. So since measure of angle 3 is 140 degrees, the measure of angle 7 is also 140 degrees. Alternate interior and the alternate exterior angle theorems say that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent and the alternate exterior angles are congruent. So let's look at some examples. Given that line J is parallel to line M, so we're going to mark that with our arrows that mean parallel. If the measure of angle 4 is 30, what's the measure of angle 5? Well, those are alternate interior angles. Therefore, the measure of angle 5 has to be the same as the measure of angle 5. So the measure of angle 4 and the measure of angle 5 are congruent, so they're both 30 degrees. If we're given that J is parallel to M, the measure of angle 2 is 120 degrees, then the measure of angle 7, those are alternate exterior angles, so they're congruent, so the measure of angle 7 is 120 degrees. We can use the converse to prove that lines are congruent. If two lines are cut by a transversal, so the corresponding alternate interior or alternate exterior angles are congruent, then the lines are parallel. So, if we know that angle 1 and angle 5 are congruent, angle 1 and angle 5 are congruent. Those are corresponding angles. If the corresponding angles are congruent, then we can say that line J is parallel to line M. So we can know that lines are parallel and determine things about the angles, and if the angles follow our three rules, then we can prove that the lines are parallel. Our next theorem, if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. So, given that J is parallel to M, I'm going to mark my lines to show that they're parallel. If the measure of angle 6 is 140 degrees, what is the measure of angle 4? If they're supplementary, we know they have to add up to 180. So 180 minus 140 leaves us that the measure of angle 4 must be 40 degrees. The converse of this theorem can also help us prove that lines are parallel. So if two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. So in this picture, if measure of angle 3 and the measure of angle 5, so 3 and 5, those are consecutive interior angles, so it works. They add up to 180, then we know that line J is parallel to line M. Now in our next picture, we have a lot going on. So I'm going to use my little gray piece to help. I'm going to use my gray paper to cover up pieces I don't need to see. You might want a second piece of paper or to use your hand to help you cover up extra information as well. So the first set of angles we're going to look at, we're going to use the diagram and the given information to determine which lines are parallel. We're going to state the reason that we use to make that determination. So the first one tells us that angle 9 is congruent to angle 16. Since we're not dealing with these angles up here, I'm going to cover them up. Don't touch one. So cover those up. This is M and this is L. So 9 and 16 are alternate exterior angles. Based on our theorems and postulates from the front, if alternate exterior angles are congruent, then the lines are parallel. So that means line M is parallel to line L. On our next example, we're looking at angle 8 and angle 11. Angle 8 and angle 11. So since we're not using these angles over here, I'm going to cover that part up. Angle 8 and angle 11 are alternate interior angles. And our converse said if those are congruent, then our lines are parallel, and the lines that would be parallel are N and Q. So they are alternate interior angles that prove that N is parallel to Q. Let's look at angle 5 and angle 7. So this time we don't need to worry about the angles down here. 5 and 7 are corresponding angles. And since they are congruent, we can prove that M is parallel to L. In number 4, they have the measure of angle 6 plus the measure of angle 7 equals 180 degrees. 6 and 7, those are consecutive interior angles. Is that our set that's supposed to be supplementary? It is. So they're consecutive interior angles, which proves that M is parallel to L. The next statement says that 6 is congruent to 7. Well, consecutive interior angles are supposed to be supplementary if the lines are parallel. So there is nothing that there are no lines that we can prove parallel with that information. The measure of angle 1 is congruent to the measure of angle 9. Here's 1 and here's 9. Let's cover up our extra information. What types of angles are those? They're corresponding. And corresponding angles are congruent if they're parallel. And therefore, it proves that these two lines, which are N and Q, are parallel. Our next statement says that 1 and 9 are supplementary. Well, those are not consecutive interior angles, so there's no lines that can be proven parallel there. And finally, we're looking at 13 and 2. If they're congruent, the lines are parallel because those are alternate exterior angles. And those prove that N and Q are parallel as well. Next, we're going to look at some problems that require a little algebra. Solve for x. State the reason, our postulate or theorem, that we used. So we are given that these two lines are parallel, and we know they're parallel because they have the parallel markings. So this angle and this angle, the two that were given, are consecutive interior angles. And if the lines are parallel, what do we know about our consecutive interior angles? We know that they add up to 180 degrees. So 3x plus 120 must equal 180. So now we solve. Subtract 120. 3x equals 60. Divide both sides by 3, and we get that x equals 20. You could check your answer by plugging 20 back in for x and seeing if the two angles add up to 180. Our last example, find the value of x that makes A and B parallel. So we're trying to prove that these are parallel. If these are parallel, these two angles, which are what kind of angle? Pair. They are alternate exterior angles. If alternate exterior angles are congruent, then the lines are parallel. So if x equals 2x minus 120, then our lines will be parallel. So I'm going to subtract 2x to get our x's together. Negative x equals negative 120. Divide by negative 1. And I get that x equals 120. For your summary, compare and contrast the relationship between the measurement of the consecutive interior angles versus the other special angle pairs. Also, list places outside the math classroom where you see parallel lines. That's all for today. We'll see you in class.